Alright people, we are continuing with ray optics. It's just seeming to be a never ending topic. However, the purpose here is to cover as many variations as can. So we have dealt with certain problems in reflection, certain problems in refraction, and today we are going to specifically target the problems which have come in different competitive examinations like IIT and all. I don't know whether it is visible, but here we have two plane mirrors A and B that are aligned parallel to each other as shown in the figure. They are aligned parallel to each other. Is this visible? Let me just check here. Alright, two plane mirrors are there which are aligned parallel to each other as shown. A light ray is incident at an angle 30 degree at a point just inside one end of the plane A. The plane of incidence coincides with the plane of the figure. So the plane of the incidence is basically the plane of the figure. The maximum number of times the ray undergoes reflections, including the first one, before it emerges out of this one. So obviously there will be multiple reflections which will be forming 28, 30, 32 or 34. So let's kind of do this here. Okay, so where we have, let's see here, we have here two plane mirrors basically. These are two plane mirrors and there is a ray of light which is coming like this. There's a ray of light which is coming like this, okay, and this ray of light is basically making an angle of 30 degrees. This ray of light is making an angle of 30 degrees. So there will be a reflection produced here. Let's say this is the reflection which is produced here, okay, and if I happen to extend this normal here, okay, all right. So here we have the value to be 30 degrees. Okay, obviously this will also be 30 degrees, and let's say this is x, this is distance x. Okay, so from the triangle itself we can say that what will be the value of x. So we know that this value that has been given here, is 2 under root 3 meters. This value that has been given here is 2 under root 3 meters, and this value that has been given here, let's say this value which has been given here is 0.2 meters. So this is basically 0.2 meters. Okay, now if I happen to calculate the value of tan 30 degrees, just look at this figure. This will be x perpendicular upon base, that is 0.2. Tan 30 will have a value of 1 by under root 3, that's x upon 0.2. So x is going to be 0.2 upon under root 3. So x is going to be 0.2 upon under root 3. Okay, now let's say we have n times. So let's say this is n reflections. So let n reflections take place before the final ray emerges, before the final reflected ray emerges out. Okay, so what do we have here? So there will be n reflections before the final ray emerges out. So for every reflection the distance covered will be x. So here we have n into x will be actually equal to 2 under root 3. Alright, so here we will have the value of n as 2 under root 3 by x. So that will be 2 under root 3 by x, and that's going to be how much? That's going to be 2 under root 3 by x, that is 0.2 upon under root 3. Okay, so this under root 3 goes up, that will be 2 under root 3 into under root 3 upon 0.2. So 3 into under root 3 will be 3, and this will be basically what, 20 upon 2, so that will be 10. So that will be 30. So that will be 30. So this will be the correct answer. This is going to be the correct answer. Okay, we will have more problems here. Right, so in this one we have a container which is filled with water, and we have been given the value of mu to be 1.33. Now this is filled with water. This entire distance is 25 centimeter. That is the image that is getting formed. A container is filled with water up to a height of 33.25. 33.25 is this height that is filled with water, and a concave mirror is placed 15 centimeter above the water level. 15 centimeter above the water level, and the image of an object is placed at the bottom is 25 centimeter below the water level. So the focal length of the mirror is how much? Okay, now we know that mu is equal to real depth upon apparent depth. Mu is equal to real depth upon apparent depth. So what is the real depth here? Mu is equal to real depth upon apparent depth. So that's how much the real depth here. Okay, we'll go by case to case basis, or we can also say that the apparent depth is equal to real depth upon mu. The apparent depth will be equal to real depth upon mu. Now in this case we need to understand this. Why are we trying to do this? Okay, because this image formation is not with respect to the mirror. This image formation will automatically happen. The real depth and apparent depth thing will automatically happen even without the mirror. So that's the reason this is the. So now with respect to the mirror, the mirror, what will be the object distance? Object distance will be, obviously this is 15 centimeter, so this will be minus, this will be 15 because it is in the front. And what about this entire thing? Now this is the real depth. Okay, so apparent depth, we have to take the apparent depth. In case of the object distance, we have to take the apparent depth. So what will be the apparent depth? That will be real depth, that is 33.25 upon 1.33, and that's going to be how much? Let's just quickly check here. 1.33, and that is 33.25. So this will be 133.25. Let's say 3 is a 9, 3 is a 9, 3 1 is a 3, 133 to 2, 3 2 is a 6, 3 2 is a 6, 2 1 is a 2, and into 3 will be 3, 3 is a 9, 3 3 is a 9, 3 1 is a 3, so it will be get. So this will be 2, 3 2 is a 6, 3 2 is a 6, 2 1 is a 2, and this is 665. So let's check for 5 here. 3 5 is a 15, 3 5 is a 15, 116, 5 1, 3 5 is a 15, 3 5 is a 15, 116, 5 1 is a 5, 1 6, exactly 25. So this will be minus 15 plus 25, and that's going to be minus 40 centimeters. So the value of u has come to be minus 40 centimeter. Okay, now let's check for the value of v here. Again, the value of v will be how much? Minus, obviously this 15, that is the height of the water level from the mirror, that is minus 15, plus image, this will be real depth upon apparent depth. The real depth of the image is how much? 25 and upon mu. Okay, upon mu. So this will be how much? 133, and this is 2500. So how much will be this? 3 1s are 3, 3 1s are 3, 3 1s are 3, 133 into 2, that will be 3 2s are 6, 3 2s are 6, 2 1s are 2, so not a possible. 3 1s are 3, 3 1s are 3, 1, this will be 7, 4 1, 170, so this will be again, let me 117, right? 7 plus 8, 9, 10, okay, 170. So this will be how much? 133 into 133, let me use a calculator here. will be how much here? 7 8 7 8. My calculator is not working. Okay, no problem. Let's say 7 3 7s are 21, 3 7s are 21, 22, 7 7 8 9. Will it work for 8 8 8? 8 3s are 24, 24, 8 3s are 24, 25, 8 1s are 8 9 10. This will work. So this will be 8, that will be 1 0 5 4, right? 3 8s are 24, 3 8s are 24, 3 8s are 24, 8 3s are 24, 25, 26, 8 1s are 8 9 10, 4 plus 6 10, and 1 1 0 6, 3 7s are 21, 7 3s are 21, 22, 23, 7 1s are 7 8 9, 7 3s are 21, 3 7s are 21, 22, 23, 7 7 8 9, 9 plus 1 10, 5 3 2, 9 plus 1 10, 9. So this will be 129, right? Okay, 1290, 133. We just did a 7, right? What about 8 8 8? Or so approximately 18.7 if we take. So this will be how much? Minus 15 plus 18.7. That's going to be how much? 8 plus 5 13, 1 plus 1 2, 1 3, 33, 18.7, 8 plus 5 13, 1 plus 1 2, 1 3. So approximately this will be minus 34 centimeter, okay. So now 1 by f is equal to 1 by v plus 1 by 1 by u, okay. So if we have to calculate the focal length, obviously this will be how much? V u by u plus v. So 1 by f, so focal length will be equal to u into v upon u plus v. U plus v will be minus 40 into minus 34 upon minus 40 minus 34. So that's going to be how much? 3 4s are 12, 4 3s are 12, 1 13, 1320. That will be plus minus 74, so this will be plus okay. So 1320, where will this stand as? 74, if I do a 1320, approximately 74 ones are 74. Lot of calculations in this one, okay. IIT, 74 ones are 74, 74 twos are, so 74 ones are 74. That leaves you with 8 plus 4 12, 5 12, 580. 24 into 6, 4 6 are 24. This will do 74 into 5. What the hell? 5 4s are 20, 7 5 35, 36, 37. What is this answer coming out to be? Am I correct with the answer here? Let me just check here. The answer here. To 8, 4 is a 32, 7 is a 56, 57, 58, 59. Approximately. So this will be the correct answer. The closest answer will be this 20. Okay. So this is the calculation for this particular problem. Lot of calculations involved, of course, but this will be the right answer. Okay. 20 centimeter. Okay, a pretty easy conceptual problem from IIT, a little older one. When a ray of light enters a glass slab from air, when a ray of light enters a glass slab from air, its wavelength decreases, its wavelength increases, its frequency increases, neither its wavelength nor its frequency changes. Okay, so we have wavelength, wavelength is equal to, or rather velocity, if we take velocity is equal to wavelength into frequency. Okay, so wavelength will be equal to velocity upon frequency. Now we know that for any change in medium, frequency remains constant. So frequency remains constant. So now frequency remains constant. Velocity, we know velocity decreases. So if velocity decreases, obviously lambda will also decrease. The lambda will also decrease. So wavelength will decrease. So there will be, therefore wavelength decreases. So its wavelength decreases. This will be the correct answer. Okay. Okay, again a problem from IIT, which is basically stating that in an experiment to determine the focal length of a concave mirror by UV method. So obviously we know the UV method is what? 1 by f is equal to 1 by v plus 1 by u in case of a mirror. So this will be uv, u plus v, 1 by f. So f is equal to uv upon u plus v. That is all about the UV method to determine the focal length. Okay, the student took a pin and its inverted image from a distance keeping his eye along with PA. When the student shifts his eye towards the left, the image appears to be the right of the object pin. So let's quickly do this here. We know that when let's say this is the principal axis, and this is okay. So we have a concave mirror which is placed here. Let's say this is the focus, this is 2f. Okay, now we know that so here if you see the inverted image from a distance keeping his eye, the student looks at the pin. So this is a pin which is basically placed on the principal axis. The student looks at the pin and its inverted image from a distance keeping his eye in line with PA. When the student shifts his eye towards left, the image appears to be on the right of the pin. The image appears to be on the right side. This is the pin. The image appears to be on the right of the pin, this side. So here we can say that the image distance is more than the object distance, and this will happen only when we happen to place the object between f and 2f. See, we know this, right? We know by the characteristics of the image form that if the object happens to be between when the object happens to be between f and 2f, when the object happens to be between f and 2f, so a ray of light which is parallel to the principal axis after refraction will pass through the focus. A ray of light which is basically parallel to the passing through the focus after reflection will pass through here. Okay, and this will be the inverted image. This will be basically the inverted image of the object. Okay, so in this case the v will be greater than u only when it happens to be between f and 2f. The v will be greater than u only when the object is placed between f and 2f. So let's say the object distance here is considered as x. So this x happens to be less than 2f and it is greater than f. So this will be the simple choice out here. Okay, just by the diagrams that we know about concave mirrors. Okay, let's move on to the next problem here. Okay, here we have a ray of light a ray of light, this is basically a problem from IIT 2001. A ray of light is passing through 4 transparent media, and all these transparent media seem to have different refractive indices. Okay, mu1, mu2, mu3 and mu4, all these have different refractive indices. Okay, as shown in the figure, the surface of all media are parallel. All these surfaces are parallel. Now we know that whenever ray of light passes, by Snell's law we know that mu1 into sine theta 1 will be equal to mu2 into sine theta 2, and so on and so forth, right? This will be equal to mu3 into sine theta 3, and this will be equal to mu4 into sine theta 4. So obviously this goes on till mu n sine theta n. So whenever a ray of light passes from one medium to another, we can comfortably say that the product of mu sine theta will be a constant. So this is as per Snell's law. This is as per Snell's law. We know by Snell's law mu1 is equal to sine theta 1 sine theta. Oh, okay. So this will be basically Snell's law states that sine I by sine r is equal to mu respect to this. So this will be mu2 upon mu1. So this will be sine I upon sine r. So this will be mu1 sine I is equal to mu2 sine r. So what happens here is, whatever will be the angle of refraction here will be the angle of incidence here. So it's very obvious that for all the things that we have, mu into sine theta will be constant. Now here what it states is the surface of all media are parallel if the emergent ray CD is parallel to the incident ray, which means that AB and CD are parallel, which means that mu1 into sine theta 1 is equal to mu4 into sine theta 4, and here theta 1 and theta 4 are equal. So if I happen to cancel these, then obviously mu1 will be equal to mu4. Okay, mu1 will be equal to mu4. Here we have mu1 is equal to mu4. Okay.